Okay, good morning. Welcome back. I'm going to do a few things today. If I look at the schedule, we are on Friday, September 20th, and we're going to move on to section 2.2, but the first thing we're probably going to do is just practice one of those 3x3, the XYZ, from section 2.1. Remember when we did section 2.1, the first part of what we did on Wednesday was kind of like 9th grade review algebra, where we just had an X and a Y, two variables, two equations, and how can we solve those? Substitution, the addition-elimination method, or we can just graph them and look where the two lines cross each other, right? We're going to practice more of that. I'm actually going to have you do a project at the end of this chapter that's going to have you build your own calculator doing that. But then we went on to that 3x3. That got more complicated, right? X, Y, and Z. So we had three variables and three equations, and I think we practiced one of those. And I want to practice one more. And we're basically going to work on one example all day today. But I'm going to show you three different ways to tackle it. All right? So the example I'm looking at is in your textbook. It's on page 87, and there it is. Right there. So the first thing I'd like to do, I'm going to write this down and we're going to do this on paper here and we're going to go through this together, is go ahead and just write down this system. Now, when we're doing this, this takes like a whole sheet of paper, okay? So don't try to, squeeze this into your little tiny iPhone instructions, Dalton, whatever you were doing that day. I don't know what it was. Give yourself a nice big clean piece of paper, okay? So what I'd like you to do is write down this system, x minus y plus z. I'm going to get it written down and then I'll show you my paper here. And 2x plus 3y minus z equals negative 2, and 3x minus 2y minus 9z equals 9. Okay, we got three equations. We've got three unknowns. So, let's talk about this. What we want to do is we want to get a 3x3 down to a 2x2. And then once we have a 2x2, then we can go back and do what we did before with the elimination or substitution and finally get it into a one equation and one. And once we get it down to one equation with one, now it's easy. Now it's like 8th grade, right? And then we can solve for that one equation, and then we back substitute to solve for the second one, and then take those two and back substitute to solve for the third one, and we're done. Okay? So our goal here is to eliminate one of these variables. Either we're going to eliminate x, or we're going to eliminate y, or we're going to eliminate z. But it's going to take a two-step process to do this. When I look at that, one of those variables looks like, hey, please eliminate me. Does one look easier than the other? Which one am I looking at? X, Y, or Z? Z. Why does Z look easy to eliminate? Lexi, why does it look easy to eliminate?
Well, there's just the 9. Well, there's just one thing.
Yeah, I mean, I see this z and this negative z, and those are just begging for me to add them together so to go 0 z. I'm not saying you have to do that, but my brain saw that first. So let's do that. Okay? So what we're going to do is we're going to take equation number 1 and equation number 2, those two, and we're going to ignore equation number 3 for now. Okay? Let's add equation 1 and equation 2 together. So if I add the x's together, I get 3x. If I add the y's together, I get plus 2y. And if I add the z's together, I get 0 z's. That's what my goal was, right? And if I add the constants together, I get positive 6. You guys okay with that? So I wrote down 0 z, but I wouldn't have to. I could ignore it. So it's 3x plus 2y equals positive 6. Are we happy with that equation? Okay. Now I got to go to two different equations, whether it be the first and the third or the second and the third, it doesn't matter, but I got to choose two different equations and I need to eliminate z again. Okay, so the question is, should we do it with equation 1 and 3 or should we do it with equation 2 and 3? And it doesn't really matter. Which one looks easier? I heard a 1 and 3. Should we do 1 and 3? Okay. What am I going to have to do to equation 1 so that when I add it to equation 3, it's going to cancel for me? Multiply by 9. Do you guys agree? If I run a 9 through the top equation, and then add it to him, it should work. So first let's run a 9 through the top equation. It would be 9x minus 9y plus 9z equals 72. You guys agree? What we're going to find is as we do this, the most important thing of all is keeping your work straight and understanding what you're writing down and being organized. That's really what this is. The adding, subtracting, multiplying, and dividing is not the tough part. It's the focus to detail and attention is kind of the tough part. These are very easy to screw up and make a mistake. I said that on Wednesday. You miss one negative sign and your whole world blows up, right? So I ran a 9 through the top. Now I'm going to rewrite my third equation. I'm just going to rewrite it so that it's right underneath it. And now I'm going to add these two guys together, and I get 12x negative 11y. Notice the z's cancel. That was my goal, right? 0z, and that is equal to 81. So now I have two equations that I put in a box, and those two equations, neither one of them has a z in it. So I'm like halfway home here, right? I changed a 3 by 3 into a 2 by 2. So now let's just focus on the 2 in the box. What method do we want to use here? Do we want to use the addition-elimination method, or do we want to do a substitution? I know which way I would go. Which way would you guys go? Elimination. I think that because if I start doing substitution, if I'm going to solve for x or y in one of those, I'm going to introduce fractions. And it's not that I can't handle fractions. I'm a big boy. But why would I want to do fractions if I don't have to, right? So let's do the elimination addition method. So I'm looking at these two in the box. One of these variables, x or y, looks easier to eliminate than the other. Which one? Predict which one I'm thinking. The x. Why? Yeah, if I run a negative 4 through the top one, I'm going to get negative 12x, and that's going to work out nicely with my positive 12x. Now, I could do the y. I could do the 2 and the negative 11, but that's going to take an operation on both equations to make it work, right? Like, for example, I could change them both into 22s. I could run an 11 through here and a 2 through here, and I'd get negative 22 and positive 22, but then I got to do two operations instead of just one. Again, let's work smarter, not harder, right? So we're going to run a negative 4 through this guy. So that would be negative 12x minus 8y equals negative 24. I multiplied it by negative 4, right? Now I'm going to recopy my other one. 12x minus 11y equals 81. I'm going to add these together. Notice my x's are gone. Did I do that right?
No,
It's a negative 12x and a positive 12x, right? So if I add those two together, I get 0 x's, so they're gone. So I got negative 19y equals, do this in my head today. What does that equal? 57? Okay. Are we comfortable? Did I screw something up? Nope. And now I can solve for y. And what's that going to give me? Negative, right? Because 57 divided by negative 19 is negative 3. So y equals negative 3. I've got one of my answers. One of them. I still need x and z, right? Doesn't matter which one you solve for first. Okay? So, now we can take my y and we can back substitute. So I can just find an equation that has an x and a y in it. This one looks like a friendly one. So now that I know what y is, I can just plug it in, right? So I'm going to rewrite that equation, 3x plus 2y, but instead of y, since I know that y is negative 3, I just plug it in. See what I did there? So now I can say 3x minus 6 equals 6, so 3x is equal to 12 and x is equal to 4. Now I have two of my solutions, right? And finally, I want to solve for z, so I'm going to go way back up to the very beginning. And I'm going to probably use this first one because it looks nice and easy, right? I could use this one or I could use this one. It doesn't matter. But I'm going to use this first one and I'm going to rewrite it. But I know that x is actually equal to 4. So instead of x, I'm going to write 4. I know that y is equal to negative 3, so minus negative 3. And I don't know z yet, and that equals 8. And now I can solve this guy. So I got 4 plus 3 plus z equals 8. 7 plus z equals 8. Therefore, z must be equal to 1. And after all that work, I have all three of them. And the way that we can write this, you'll often see it as an ordered triple. So they write it as x comma y comma z like that. So your answer could be written as 4 comma negative 3 comma 1 as an ordered triple. And that's my answer, 4, negative 3, and positive 1. That was kind of a lot of work, right? But we got it down to where we wanted to go. So just so you can feel this, you don't have to do this. I'm just going to show you something graphically. I'm going to pull up my GeoGebra. When we were solving the 2x2 systems, make my font size a little bigger here. When we were solving the 2x2 systems, we knew that it was a line, and then we looked for an intersection of that line, which ended up being one single point, right? That's when we only had x and y. When we graph on this, we have an x-axis and we have a y-axis. It's two-dimensional, right? It's a flat surface, x, y, two-dimensional. But when we do one that has x, y, and z, what's going on now? Like, where the heck is z? We know where x is, and we know where y is, but where's z? Yeah, it's 3D. It's coming out from the whiteboard like this way, or back behind the whiteboard. 3 dimensions, right? So, and again, you don't have to do this, and I'm not going to test you on this or anything, but I can get rid of this graphics view, and under view, instead of graphics, notice there's one called 3D graphics. So if I do the 3D graphics, and I close my 2D graphics, notice now I have x, y, and the green one is z. See how it does a 3-dimensional type thing? So I can actually type this in. If I type in x minus y plus z equals 8, that was, whoops, not 9, 8. That was my original equation. Do you guys agree? X minus y plus z equals 8. Notice what it does. It's not a line, it's a plane. So it looks like a sheet of paper cutting through 3 dimensions, right? So you could think of it like, it looks like a sheet of paper that goes like this, but it goes forever to the left and forever to the right and forever up and forever down, okay? So that was one of my planes. I just graphed a plane. That was my first equation, x minus y plus z equals 8. How about the second one? 2x plus 3y minus z equals negative 2. Enter. Now do you see there's 2 pieces of paper there? The dark gray one is my original kind of 2-dimensional plane or whatever. But then I have this blue and this blue. They're like these sheets of paper. I know it's hard to see, right? And you can actually take this and you can look around and there you can see the 2 blue sheets of paper a little bit better when I do that, right? Okay, but we have a third one. We have a third sheet of paper, and that's going to be 3x minus 2y minus 9z equals 9. Enter. And now I have 3 sheets of paper going in all kinds of crazy manner, right? Think about 2 sheets of paper. If 2 sheets of paper intersect each other, do they intersect at a point? No, they intersect at a line. It's a full line, right? And so if number 1 and number 2 intersect at a line, and number 2 and number 3 intersect at a line, I would then have 2 lines, right? And what do you think those 2 lines are going to intersect at? One single point, right? So 2 planes intersect in a line, but 2 lines intersect in a point. So I can actually go to my Intersect Two Surfaces button. Let's say I take the first one and the second one. So I'm going to choose that. I'm going to say, how about the first one and the second one? It spits out some line, okay? And then I'm going to intersect the second one and the third one, the second one and the third one, and that spits out some line. It's in a goofy notation, by the way. And now I can actually do a point that intersects the first line and the second line. Boom. After all that work, there's a point out there in 3D space where all 3 of these guys intersected, and notice the answer. That's the same thing we got when we did it on paper, right? So I just wanted to show you that so you could feel the difference between a 2-dimension and a 3-dimension. And if you want to tinker around with your GeoGebra on that, you go right ahead. But I'm not going to require you to. I'm not going to give you an assignment that involves that. Okay? We're going to do more of like applications with these systems. And I'm going to show you how we can solve this electronically in a split second. So we don't have to do all that work that we just did. Okay? But not yet. I want you to feel what the computer's doing first before we get there. So I want to go back to our original guy, and that was this system that we did, right? In section 2.2, they're going to show us how we can do this using a matrix, and it's what they call an augmented matrix. So if I scroll down, it says write this guy as an augmented matrix. Notice there's no x's, there's no y's, there's no z's, there's no equal sign. There's just an array of numbers. Have you guys ever seen this before? Anybody ever worked with matrices before? Did it in high school maybe? Okay. I'm not a matrix expert by any means. We have a whole course called Linear Algebra and Matrices, Math 330. You go ahead and take that course if you want, but usually it's just math majors that take that course. But I want you to notice these numbers and notice how it matches up with the original problem. This is 1x minus 1y plus 1z equals 8. So we got 1, -1, 1, and 8. Go down to the first line of the matrix. What is it? 1, -1, 1, and 8. All we're doing is we're grabbing the coefficient off the front. We're rewriting it, except we're not writing down any x's or y's or z's or equal signs. Does that make sense? So go ahead, and I'm going to grab a new piece of paper, and let me tell you, this is going to take a full piece of paper, if not more. Okay? So I want you to write down that augmented matrix and give yourself some room. It's 1, -1, 1, and 8. And then the next one is 2 and 3 and -1 and -2. And the next one is 3 and -2 and -9 and 9. And I'm going to put a little bar. I'm going to put a little bar where the equal sign would go. That straight line represents the equal sign. Are we comfortable? You can put the little brackets around the outside if you want. I'm going to skip that for now. Okay, so here's what we want to end up doing in the long run. Okay? In the long run, I'm going to write over top of this. We want to do what's called row echelon form, and I'll tell you why in a second. But row echelon form means that down the diagonal, this diagonal right here, we want each one of these guys to be a 1. A 1, right now it's a 3, we're going to change it into a 1, and right now it's a -9, we're going to change it into a 1. Okay? And then these guys right here, we want all of them to be zeros. So when we're all done, we're going to have this array that looks like this. A 1, 1, 1 with zeros underneath them, and then some number, some number, some number, and some number, and some number, and some number. That's what we're going to end up having. And think about what that's going to do for us. Think about the columns. This first column was the coefficients of which variable? These were all the x's. Yeah, these were all the x's, these were all the y's, and these were all the z's, and these were all the constant numbers, right? Well, if I got that, this equation on the bottom would then say 0x plus 0y plus 1z equals something. And if I could figure that out, I would have now solved for z, right? I can just look at this and say, oh, z equals whatever that number is. And if I know what z is, now I can move up and I can say 1y plus z, whatever it is, I'll plug it in. I'll have y plus whatever it is equals that, and I can easily solve for y. And now that I got y and z, I can go up to the top one and I can say 1x, plug in my y value, plug in my z value, equals something, and then I can solve for x, and then I'm done. So really we're doing the exact same thing that we just did when we did all the elimination and stuff, but we're doing it on a matrix instead of on the actual equations. But nothing's really going to change, okay? So keep in mind what we're trying to accomplish, and we'll do this step by step here, okay? I'm going to label this one row 1, row 2, and row 3. These are my rows, okay? And we'll refer to them as R1, R2, and R3. Okay, remember what we want. We want 1 and 1 and 1 and 0 and 0 and 0. And then we can, whatever these three corner ones end up being and whatever these end up being, so be it. They're going to be some random numbers, right? Okay, do you guys agree that the first step is kind of done for us? That 1 is already there. So I'm good to go. So let's move down. I want that 2 to be what number?
0.
I want it to be a 0. Think about how you would do that. You're going to have to manipulate and add. Manipulate one of the equations and add it and get there. So I'm going to rewrite my row 1 because I'm already happy with my row 1 so far. Do you guys agree row 1 is cool? But I'm not happy with row 2. I want a 0 right here. So what operation can I do that's going to make this happen? What would you do if it was all the x's and the y's and the z's if you wanted to eliminate them? I need a positive 2 to cancel with a negative 2, right? How can I generate a negative 2 in this first column? Multiply row 1 by negative 2, right? Because if I take row 1 times negative 2, aren't I going to get a negative 2 in that spot? And then if I add it to row 2, I'm going to have a new row that I can insert instead of my old row 2, right? So here's how you do the row operation. We're going to say, I'm going to run a negative 2 through the first row. A negative 2 through the first row, and then I'm going to add it to row 2. Are you guys comfortable with that? Okay, so let's run a negative 2 through the top, and we'll do this all in one step. A negative 2 through the top, and then add it to row 2. So I run a negative 2. Negative 2 times 1 is negative 2. Add it to him. What do I get? 0. Okay, keep going. Negative 2 times him is positive 2. Add it to him. 5. Negative 2 times 1 is negative 2. Add it to him. Negative 3. And negative 2 times 8 is negative 16. Add it to him. Negative 18. And I just produced a new row 2. And notice my new row 2 has a 0 in it just like I wanted. That was my goal, to get a 0 in that spot, right? Now I'm just going to rewrite row 3. Okay. That was a lot of work just to get that 0, right? But it's not that it was difficult, it was organization. So now I got my 1. Now I got my 0. Let's keep moving down. I want him to be what? 0. So again, think about how you're going to be able to do that. It's a 3. I need a negative 3 to cancel with him. Do you see how I'm going to generate that negative 3? I'm going to use my row 1 to do it. What am I going to run through row 1? Negative 3. So I'm going to run a negative 3 through row 1. Negative 3 through row 1. And after I do that, I'm going to add it to row 3. Right? Okay, so I'm going to rewrite row 1. And I'm going to rewrite row 2 because I'm happy with them so far. I'm generating a new row 3 is what I'm doing. Generating a new row 3. So let's run a negative 3 through here. So I get negative 3, add it to that 3, 0. Negative 3 times him gives me positive 3, add it to him, 1. Negative 3 times 1 gives me negative 3, add it to him, negative 12. And negative 3 times 8 gives me negative 24, add it to him, negative 15, right? And after you do these row operations, you can get kind of fast at doing the multiply, add, multiply, add, multiply, add. I now have a new row 3, and he's good to go, right? Okay. The only two guys I have left is I need a 1 here, and I need a 0 here, right? Now, there's a couple different ways we could go here, but be a little bit clever. One thing that we can always do is we can take two equations and just switch them. I mean, that doesn't change any equations at all. It doesn't matter what order we write them down. Now, we can't switch the x, y, and z columns, but these are just 3 equations, so we can write them in any order that we want. When we started with the original problem, we could have rewritten them however we wanted. So, do you see kind of a shortcut that's going to get us a 1 in that middle spot? Couldn't I just take my row 2 and my row 3 and swap it? So let's do that. I'm going to rewrite my top one because I'm happy with him. Okay, now I'm going to make row 3 into row 2 and row 2 into row 3. So all we're doing is we're swapping the 2 rows. So I'm going to make row 3, I'm going to write him right here. And row 2, I'm going to write him underneath. Little clever trick. That's about as easy of a row operation as there is by just flipping them, right? I am almost home free. There's 2 numbers that I still need to change, right? The negative 3 needs to become a 1, and this guy needs to become a 0. Let's tackle that 0 first. How can I produce a 0 here? Think about the row operation. Who's going to nicely cancel with my 5? This is where it gets a little sticky. What happens if I ran a 5 through the row 1 and I added it to him? Would that cancel the 5s? It would, but yeah, it would make my 0 into a 5, and that would undo all that work that I just did to do that. So let's not do that. What happens if I use row 2? What should I run through row 2? A negative 5. Yeah, if I do a negative 5 through row 2, a negative 5 through row 2, and then I add that to row 3, I should be good, right? So I'm going to recopy my top row because I'm happy with him. Okay. I'm going to recopy my second row because I'm happy with him. And now I'm going to run a negative 5 through row 2. So negative 5 times the 0 added to the 0 is going to give me 0. Negative 5 times the 1 is negative 5. Added to the 5 is going to give me 0. That's what I wanted. And negative 5 times negative 12 is positive 60. Add it to negative 3, I get 57. And negative 5 times negative 18 is positive 90. And add positive 90 to... no, I screwed something up. Oh, I'm sorry, positive 90. And what's positive 90? I screwed something up.
It's not 90.
Oh, what's... I'm sorry, I was taking it times the 18. See? Organization and clarity. It's negative 5 times negative 15, which is positive 75. And what is 75 combined with negative 18? 57, right? Okay. Yeah, it's negative 5 times negative 15 plus the negative 18 is 57. I am almost home free. The only thing I need to change now is the 57. And how could I do that? I want him to be a what? A 1. So can I just run a 1 over 57 fraction through there? So if I take row 3 times 1 over 57, I should be good to go, right? So I'm going to rewrite my top guy. 1, negative 1, 1. Can you guys feel the pain? Like, this is terrible, isn't it? Okay. That's what I wanted you to feel. I wanted you to feel the pain. I'm going to rewrite this guy, 0, 1, and negative 12, and negative 15. And I'm going to run a 1/57th through this, which is going to give me a 0, a 1, and a 1, right? I'm going to multiply 1/57th through there. So a 0, a 1, and a 1. And finally, I have what we call row echelon form. You might have heard of the term echelon before. You ever watch the geese fly? Do you ever notice they fly in like this staggered pattern? One back, one over, one back, one over, one back, one over. That's an echelon. Or fighter jets do the same thing, right? The echelon is the 1. Over, over, over. That's why they call it the row echelon form. Now, if we remembered that these were all my x's, these were all my y's, these were all my z's, and these were all my constants, what this is saying is 0x plus 0y plus 1z equals 1. So immediately I have solved for z. Do you guys agree? What is z? 1. Z is 1. So I got that taken care of. Z is definitely 1. Okay? Now I've got 0x plus 1y, so y, minus 12z's. Well, I know that z is equal to 1, so I can just substitute him in, is equal to negative 15. So y minus 12 equals negative 15. Y equals, add 12 to both sides, negative 3. So I got my y, and I got my z. And I'm almost done. Now I've got x minus y, so I'll write this down here, x minus y, but we already know that y is negative 3, so minus negative 3, plus 1z, which we know to be 1, and that's equal to 8. So I got x plus 3 plus 1 equals 8. So x is equal to 4. So my answer is 4, 1, negative 3. And that's the same answer I got when I did it on the computer, and it's the same answer I got when we did it the way we started class today, right?
So we don't have to do it like this then?
Yeah, so here's what I'm going to show you now. That is what we call taking an augmented matrix and going through and doing row operations, okay? Why would we ever want to do that by hand? Purely for understanding the conceptual thing of what the x's mean, what the y's mean, what the z's mean, what it means to just distribute a number through and add. We use the addition elimination method constantly, didn't we? Okay, so it's an exercise in algebraic fluency is what it is. Can you make sense of the problem and persevere in solving it? Can you reason abstractly? We just have a bunch of random numbers in a matrix that don't even mean anything to us. It's very abstract, right? There's no labels on anything here, okay? So, and you're right, Matthew, we're not going to do that. Like, I could give you one of those to do on a test, but holy crap, it takes 18, 19 minutes just to do it, right? That's not a good use of our time, right? So this is what we call row echelon form. Row echelon form. There's another form that's even better. It's called, let me get this here. Instead of row echelon, it's called reduced row echelon form. Okay? Here's the difference between reduced and row echelon. Reduced it looks the same right here. All of that is the same. Okay? The difference is that the rest of the numbers are also going to be 0, 0, and 0. Imagine how easy it would be to identify your three answers if it was in reduced row echelon form. Because now you have no x's and no y's plus 1 z equals this. Therefore, that must be my answer for z. And here I'd have no x's, 1 y, no z's equals that. Therefore, that must be my answer for y. And then same thing here. I got x plus nothing equals that. Therefore, that must be my answer for x. So if you can get it into reduced row echelon form, you can identify your three answers in half a second. All you got to do is look at it and you can see your answers, right? Now, could we take the guy that we just worked 20 minutes on and get it into reduced row echelon form? Yeah, we can, but I'm tired of doing row operations, right? You guys got your GeoGebra open? Or a graphing calculator. These guys can do it too, but we'll do it on the GeoGebra since I know you guys all have that. Okay, I'm going to get out of this. I'm just going to close my 3D graphics view. I'm going to go and open up a spreadsheet. I want my spreadsheet view. Have we done the spreadsheet yet? I think we did when we were plotting points and stuff like that. Okay, I'm going to use my spreadsheet to enter all these matrix numbers, and then I'm going to use it to create a matrix. So let's go back to our very original problem. Our original matrix was a 1 and a -1 and a 1 and an 8. Do you guys agree that was the top row? And then the next one was 2 and 3 and -1 and -2. You guys cool with that? And the other one was 3 and -2 and -9 and 9. Okay, so I've got all of my guys punched in. I'm gonna just erase. This was all the stuff I did earlier. Okay, I got all my guys punched in. So now you can just drag over all of it, kind of highlight it. You guys got it all highlighted? Right click on it and go create matrix. And it spits out matrix 1. They call it M1. M1. Do you guys agree that that's the matrix that we used earlier? The only thing missing in this form is they don't have that little line that divides the x, y's, and z's from the constants, but you guys know it's there. Okay?
Where's spreadsheet
Go to View, and then Spreadsheet. And then once you're done with the spreadsheet, we don't need it anymore. I'll wait till everybody gets there and has their augmented matrix. They call it M1. If we do another one, it'd be called M2, M3, M4. Are we ready?
So what's the...
Do you have your matrix up, like mine, M1?
How do you put it in the matrix? I was entering the numbers.
So what I did is do you get all this?
Yeah.
Okay, right click on it and go create matrix. And you should get an M1 like mine. Okay, are you there? Okay, what form did I say we were most interested in? There's echelon, row echelon form, and then the best one is reduced. So go down to your input and start typing the word reduce. And it'll pop up, reduced row echelon form. See it? Select that, and it's going to ask you which matrix do you want. You can type in M1. I think, who's got a Mac? Aaron, you got a Mac? I think Macs require you to do M_1. Check it out for me. Everybody else can just type in M1. Reduced row echelon form M1, enter. And it did all of that work for us. It got the zeros where we wanted it. It got the ones where we wanted it. And notice even in the top 3, it put zeros in for that too. So immediately, if you understand that this column is the x's, and this column is the y's, and this column is the z's, you can now see that x equals 4, y equals 3, and z equals 1. So we've done the same darn problem for 40 minutes, and we just did it 3 different ways, right?
So do I have to just write in reduced?
Yeah, type the word reduced. It'll pop up right there. Click on it. Now either type M1 or M_1. I don't know what works. Try it. Just, oh, you got to put it where it says the word matrix though. It's saying put the matrix here. Yeah. So erase the word matrix and erase those two. That might work. I don't know. Hit enter once. Yeah. Erase those brackets, those 2 brackets, and go M_1. No, that didn't work either. Try M1. I don't know if Apple updated hit that. There it is. Okay. I think Apple might have updated that finally. Okay. Much, much easier. Do you guys agree? Okay. So what I really want you to get out of this matrix stuff is we're going to take like these word problems and blah, blah, blah. I want you to understand how to build a matrix. Now I've shown you how the solving process works, okay? But when we solve guys like this, we are not doing it by hand. We're doing it with technology, right? So I want to look at, I'm going to go back up to page, I think it's page 73. Where are we at here? I'm going back up to the previous section, page 72. Where are you at, page 72? Okay, you guys see example 13? Chad is trying to plan a meal. That's what we're going to work on here. Chad is trying to plan a meal. What I want to do is make ourselves a little chart, which we can turn into a matrix, which we can have our calculator solve in a split second. So the difficult work here is going to be the organization of building the matrix. Solving it is going to be super easy. Okay? So go ahead and read that. Chad's planning a meal with specific nutritional goals. He wants to construct a dish that contains 3 things: rice, tofu, and peanuts. Rice, tofu, and peanuts. Some combination of rice, tofu, and peanuts. And he wants to get 30 grams of protein, 14 grams of fat, and 50 grams of carbohydrates. How much of each ingredient should he use? Okay, so let's make ourselves a little chart here. And let's see here. Let's make ourselves a chart that goes, it doesn't matter if we go, this way and this way, or this way and this way, however we turn it, but we're going to end up having 3 equations, right? So if I make a chart that goes, let's go R for rice, and T for tofu, and PE for peanuts. Those are our 3, that'd be like our X, Y, and Z. You guys comfortable with that? But we're not going to use X, Y, and Z. We're going to use R, T, and PE because we can identify that as rice, tofu, and peanuts. Are you comfortable with that? And then, as far as the protein, fat, and carbohydrates, we can go, I'll go PR for protein, and F for fat, and C for carbs. Okay? So we're going to have row 1, or equation 1, is going to be a protein equation. Row 2 is going to be a fat equation. And row 3 is going to be a carb equation. All right? And so I'll put in my bar for my equal sign. Okay? So now notice he looks up the content. It says 1 cup of rice provides 0, 44, and 4 of protein. So they screwed us up because they put it in a different order. But remember, this is rice, right? So what does rice provide? How much fat? 0. See where I put that 0? It might help if I do this. There. That might help. So rice produces how much fat? 0. Rice produces how much carbs? 44. Rice produces how much protein? 4. I did PR and PE, so I didn't mix up my protein and my peanuts. See how I did that? Okay. How about tofu? For fat, 10. Carbs, 5. And protein, 20. And how about peanuts? Fat, 72. 31 for carbs, and 35 for protein. Okay, so if I took all the rice protein, tofu protein, and peanut protein, it's going to give me a total of a protein, right? And what's that total? What are we shooting for? 30. We want 30 is what we're interested in. And how much fat are we interested in? 14. And how much carbs are we interested in? 50. Okay. There's our matrix, right? So go to your GeoGebra. Go to your spreadsheet. I'm going to get rid of the 2 that I had up there before. I'm just going to go delete. And I'll delete these from my spreadsheet. I'm going to enter 4, 20, 35, 30. So 4, 20, 35, and 30. 0, 10, 72, and 14. 44, 5, and 31. And 50. And once I have that all entered, I'm going to create my matrix by highlighting it, right-click, create matrix, and there's my matrix. Now notice there's no labels on GeoGebra, right? So we have to keep our organization straight. We have to know that the first column is rice, tofu, peanuts, and the last column is total. And then we also got to know that equation 1 is my protein, equation 2 is my fat, and equation 3 is my carb, right? So what are we interested in here? Yeah, we want reduced row echelon form, but then let's do that. So that's the easy part. That's the solving part. That would normally take us a half hour, but our computer will do it for us super fast. M1. Okay. So we got an answer. You should get the same answer I got. Question is, can you interpret that answer? Like, do you even know what that matrix means? Because you got to be able to explain what this is. So let's go across the top, that 100.98. What does that even mean?
That's how many cups of rice you need.
That's our rice, right? 1 rice equals 0.98. So if we do 0.98 cups of rice, we're good to go. How about the second row? The tofu. How much tofu do we want? 1.27 cups. And then if we did the third row, it says we need 0.02 cups of peanuts, so not very much peanuts. And if we did that, we would get exactly the 30, 14, and 50 that we were interested in. So let's check our book. Our book goes through, now watch what the book, this was from the previous section. So this is before we even got to matrices, by the way. They solved it the section 2.1 way. And there it was. Protein was 0.0176. Peanuts. Ours rounded it to 0.02. If I went to options and rounding and went to like 4 decimal places, I could round it out to more decimal places, right? And then what did we get for tofu? 1.273. There it is. And what did we get for rice? 0.979. There it is. Okay? And even the textbook, look what the textbook says after this. This particular system was rather unpleasant to solve. Because it is. It's awful, right? So that's where they lead us into the next section that says, let's learn how to use a matrix. And then after that, let's learn how to use a matrix with technology. Okay? So what's the ultimate goal here? Figure out how to construct the matrix. And then after you're done solving it, figure out what the final answer even is telling us. That's the thing here. The solving part, easy. As long as you know how to use the technology, and you'll get some practice doing this, and we'll kind of continue on with this idea next week. So have a good weekend. Go ahead and work on your quizzes. Now you can work on 2.1, 2.2.
When is the car project?
The car project is going to be due sometime next week. We'll talk about that. How's that going, by the way?
Good.
Moving along on it? Anybody done? I haven't checked any of your shared folders yet. We'll talk about it next week. Okay, have a good weekend.
Thank you.
See ya.